All right, our next speaker is Ed Van Dyne, and his title is Apollo Hybrid Solar Thermal Steam Engines. Wow.
Good evening, everyone. If your home had a 24/7 power system that produced electricity, heat, hot water, and air conditioning, saved you $1,000 a year, and cost the same as your current HVAC system, what would you think? Well, the world problem we have is coal, primarily. When I was in China 3 years ago, I could barely see across the street. I could not see 2 blocks down at noontime during the day, and the white building across the street was an orange-brown color. So our solution is coming from the fact that the source of the sun's energy gives us enough energy every hour to produce enough energy to supply every human energy need for a year. How are we harnessing the sun's energy? We're using it with evacuated solar tubes that are now mass-produced and much higher efficiency than solar PV. These tubes generate heat, and we use that heat in a mechanical engineering approach to be able to basically take steam and run a steam engine. Very old technology combined with a chiller that gets us over 50% efficiency in our system. What's a chiller? A chiller is a very old device developed, actually demonstrated in the 1890s World's Fair in Paris, that takes heat and turns it into cooling. And so I won't go into the science of that. That'll take much more than 15 seconds. We're then adding combustion as a backup energy. So we run natural gas or propane through a catalytic combustion system so that we have very clean combustion and we can give you 24/7 power access. And we don't look like that coal-fired train on the right-hand corner. Our steam engine fits in a box together with the chiller. It's only 4 feet tall and about 30 inches by 30 inches. And so the total system sits beside your house together with the solar panels on the roof. The solar panels here feed the heat energy down to the steam engine. It boils water. The water drives the steam engine. The waste heat from the steam engine drives the chiller. The waste heat from the chiller drives your hot water. And so the whole system works day or night as a system next to your house that gives you all those forms of energy. In the future, we'll even have a system that can run on garbage. I used up my 15 seconds. Our system compared to the competition, solar PV gives you just electricity when the sun shines unless you add very expensive batteries to that system. Normal HVAC just gives you heat, hot water, and air conditioning, whereas our system can give you that 24/7 backup. When you compare the technology to coal, we have a 1/3 the carbon energy footprint as a coal-fired power plant when you just look at the electricity alone. But when you look at the cogeneration benefits of the whole system, it's about a 7-to-1 reduction in carbon emissions. It'll go on 2,000 to 5,000 square foot homes and small commercial buildings. There's a $173 billion market for this technology. HVAC contractors can install it. And in the third world, we'll modify the system so that it can provide clean, fresh drinking water for third world countries and villages by just changing how the system works and operates. We'll take the chiller energy and basically instead of air conditioning, we'll make a refrigerated room to be able to provide refrigeration for a farm or a village or a school. And we'll have a backup energy that can run our pellet stove system that will today people actually use pellets and wood. This system will be able to burn wood chips, cow chips, or even garbage to be able to provide a backup energy for the third world. Our technologies are all proven. They've been around for many years, sometimes 100 years, and it's combining all those technologies into a complete system is what the innovation is in our system, so that we can provide a 7 to 10 year payback for the consumer here in the first world and provide efficiencies and backup generation power so that you have energy independence for your house and have all the forms of energy your house needs day or night and in any weather. Thank you very much.